Hello everyone and welcome to this workshop. My name is Alex and today I'm going to show you how you can interact with the MultiversX blockchain using Python. We will query account state and then we're going to create, sign and broadcast transactions for sending tokens and interacting with smart contracts. For this workshop, we're going to use the official Python SDK, which is currently at version 2. You can check out the code on GitHub or download it straight from PyPy. Let me walk you through what we'll do today. So first, we'll query account state to get the balance of the tokens for both native tokens and ESDT tokens. After we fetch the balance, we will send these tokens to some other addresses. In the second part, we're going to deploy and interact with the other smart contract, but without using its ABI file, so without using the ABI aware components. If available, you should always use the ABI since it makes things a lot easier. As you may know, the ABI of the contract is a JSON file which provides a description of the contract's interface, including the endpoint it exposes, their arguments, and the return times. Using the official Python SDK, you can interact with the contract whether you have the ABI file or not. In the end, we're going to interact with the lottery smart contract, but this time using the ABI file. As you may know, the lottery smart contract it's a bit more complex than the other smart contracts. Okay, let's get started. So I've created already a virtual environment where I've installed the SDK and also created the Jupyter notebook to run the code because it makes it a bit easier and it looks a bit cleaner. To keep the workshop more focused and a bit shorter, I've already prepared the code already, but you should be able to follow along because the code, a link to the code will be in the description of this video. So in the last releases, we've introduced entry points, which in my opinion are pretty cool because they make things quite a bit easier. So what we're going to do today, we're going to use the DevNet entry point. So this is hooked up to the DevNet API, the MultiversX public API. And we're going to start to query the account state. We're going to first fetch the balance, the EGLD balance, and then we're going to fetch the balance of an ESDT token. Okay, so to simply get the balance, we import the address and the DevNet entry point from the SDK. We create an entry point from which we then get the underlying inter provider, which is the API the entry point uses. We're gonna be using Alice's address today. So we create a new address object, and then we simply call the getAccount method of the network provider's class. If I run this cell, let me just run it real quick. We see that the EGLD balance is 132 and quite a few digits. This is keep in mind this is the denominated value, so it's not the EGLD full amount, let's say. And the nose is 18,702. That's pretty easy. Let's move on to getting the ESDT token balance. This is very similar to the step we've done above. Again, we initialize the entry point, we get the API, but now this time because we want to get the balance of the token chocolate E98F2B, we have to initialize it as a new token, and then we're going to call the getTokenOfAccount method, to which we also pass the token. So if I run this, we're gonna see that Alice has quite a few quite a few chocolate tokens. Okay, let's move to some more interesting things now, because we know that Alice has a few EGLD in her balance. We're gonna transfer some EGLD to Grace. I'm gonna show you how you can do both transfers using both the controller and the factory. Usually we recommend using the controller when you're doing some quick scripts or spinning up some small applications. But if you are programming backend applications, let's say, we suggest using the factories because it offers you a more granular approach to creating and signing transactions. The controllers basically need a full account to create a transaction because they also fetch the nonce of the network and sign the transaction. But using the factory, you only need the sender's address, and then you can add the nonce and the signature for the transaction after the transaction has been created. So to send EGLD using the controller, we get the entry point. We initialize the entry point from the DevNet entry point class. You see that now we also pass it the with guess limit estimator argument. What this does is before setting the guess limit on the transaction, it simulates the transaction on DevNet, and it allows us to get a more accurate representation of the guess limit that the transaction will require. If you hover the DevNet entry point class, you'll see that you can also specify quite a bit more arguments. You can also provide a custom URL if you're using some third-party API provider. You can specify the network provider kind, which could also be the proxy or the gateway. We see that we have the guess limit estimator flag that we've also provided, and we also have a guess limit multiplier argument that can be used if provided to multiply the estimated guess limit with a multiplier. So we make sure that even though there might be some differences in guess from the time we simulate the transaction to the time we actually broadcast it to the network and then execute it, we can use this guess multiplier to increase the value. So let's say if I do a simple move balance, the guess limit is going to be 50,000, but if I use a 1.5 multiplier, the guess limit set on the transaction will become 75,000. So it's like a buffer. Okay, so after we initialize the entry point, we are going to be sending from Alice to Grace. We have the path to Alice's PEM file. As you may know, PEM files are not really recommended because they provide no security. But when doing tests or small tutorials or workshops, they're very easy to use. So we're going to be using them today. And then I'm going to initialize an account from the PEM file. I'm also going to fetch the nonce. So I can fetch the nonce straight from the entry point, calling recall account nonce for Alice. I set up Grace's address, and then from the entry point, we initialize the transfers controller. This is used for transferring tokens, both EGLD and ESDT tokens, including fungible, non-fungible, semi-fungible, and all kinds of tokens that the network supports. We're going to call the create transaction for transfer method, to which we simply pass Alice's account, Alice's nonce, the receiver of the transaction, which is going to be Grace, and the EGLD amount we want to transfer. I think this is a little less than 1 EGLD. It's probably 0.00 some 1 EGLD. And then using the entry point, we're going to also send to broadcast the transaction to the network, basically. And if I run this cell, we're gonna see that we get this transaction hash. And if I copy this and move to the Explorer, we're gonna see that we've sent from Alice to Grace 0.0001 EGLD. Okay, let's do the same thing using the factory, which is very similar. I'm not gonna spend too much time on it. Again, we get the entry point, initialize the account, and also set up the nonce. Instead of getting the controller from the entry point, we now get the transfers transactions factory. We then call the create transaction for transfer method, set the sender, the receiver, and the amount we want to send. And after the transaction has been created, we now set the nonce afterwards, and also we have to sign and apply the transaction for the signature. Now, if I run this cell and copy this takes hash, let's paste it here, we're gonna see that we've sent another 0.001 EGLD from Alice to Grace. Cool. Now let's move on to transferring ESDT tokens. Let's see how we can do that. Again, both examples are going to be using the controller and the factory. We get the entry point, we initialize the entry point from the DevNet entry point, set up Alice's account, set up Grace's address, and now because we want to send the chocolate token, we initialize a new token with the identifier chocolate E98722B. We then create a token transfer to which we pass the token we want to transfer, the one we've created here, and the amount we want to transfer of that token. So keep in mind the amount expects the denominated value. So here, because the chocolate token has 2 decimals, we are only sending 10 tokens. So this is 10 tokens, but with 2 decimals, we have to type it as 1000 tokens. We're gonna get the same transfers controller from the entry point, and then we're gonna call the same method, create transaction for transfer. We also have dedicated methods to transfer both native tokens and ESDT tokens, but we also have more of a generic method, which makes the difference. It's by itself when sending native and ESDT tokens. So very similar to before, we pass it Alice's account and Alice's nonce. We also set the receiver, but here instead of sending native tokens, we have a token transfer which accepts a list of token transfers. So we pass the transfer we've created above. And then again, we broadcast the transaction using the entry point. So allow me to run this real quick. I get another transaction hash, which I'll paste it here on the Explorer, and we see that the transaction is pending. And if I reload this really quick, we see that we've indeed done an ESDT transfer. We've transferred 10 chocolate tokens from Alice to Grace. Cool. Let's do the same using the factory real quick. Very similar as I've said, we set up the entry point, Alice's account, the token transfers. This is all very similar, all the same actually. Here we get the factory, to which we pass indeed Alice's address, the receiver, and the transfer. Afterwards, we set up the nonce, and then we sign the transaction using Alice's account, and then we broadcast the transaction. We get another transaction hash. And if I copy the transaction hash, we see that 2 seconds ago, we've sent from Alice to Grace again, 10 chocolate tokens. Cool. Now let's move on to a bit more interesting things, to smart contracts. First, we're gonna interact with the ABI, with the other smart contract without using its ABI file. We can do this because the other contract, it's quite a simple contract. It only has to be initialized with a value, and then each time an endpoint called add it's called, it only adds a value to the previous value stored in the contract. Okay, so the first step is to deploy the contract. For this, we'll also use the entry point, the DevNet entry point, again with the gas limit estimator, because we want to estimate the gas before sending the transaction to the network. We set up Alice's account. We have the bytecode for the other contract, the WASP file that we got after building the contract. We're going to get this time the smart contract controller from the entry point, and then we're simply going to call the create transaction for deploy method, to which we pass Alice's account again, Alice's nonce. We also have to pass the bytecode for the contract. So we pass it the other bytecode, and then for the arguments, I know that the constructor of the other contract expects a big unsigned integer value, so I can simply import this from the SDK as well. We have to import this from the ABI module of the SDK, so we have to do a separate import, and we have plenty of types to import, so we can use quite a few of them, but we're going to use big unsigned integers today, and we simply initialize the contract with the value 0, so it will start counting from 0 basically. Then I send the transaction hash. I send the transaction to the network and then wait to get the hash back. And we also have a method for the controller to await for transaction completions and to parse the transactions after they've been executed. So what this does, basically, after deploying the contract, we get the contract's address that will then use to call the contract and interact with the contract. And after what this method does, the await completed deploy, basically awaits for the transaction to finish executing, and then it parses the transaction to extract the contract's address. So if I run this cell real quick, we see that the transaction hash is already provided. And now, because the transaction has been executed and it's a success, we see that we got the contract address, this one. Now I'm going to set up this address as my other contract's address, so I can use it in later code snippets. Cool. Now, after we deploy the contract, we can simply call the add function of the contract. Again, we initialize the entry point, we set up Alice's account and also the nonce. We get the smart contracts controller from the entry point. And now, because we want to call a function of the contract, we simply use the create transaction for execute method. To this method, we, same as above, pass the sender and the nonce. We also have to pass it the contract's address, which is the address we got after deploying the contract. We're going to specify the function we want to call, which is called add. And we also need to provide the arguments for the function. If some functions don't require any arguments, this could simply be an empty array. But because I know the add function expects a big unsigned integer value, I'm going to pass it the value 7 here as a big unsigned integer value. So I'll run this cell really quick. And if I copy this and paste it in the Explorer, we see that indeed we've called the method add with the value 7. So now, if we move to querying the contract, this means reading from the contract, reading its state. Again, we do this by initializing the entry point. For querying the contracts, we don't need to create and send the transaction to the network, because when querying a contract, we simply call read-only method of the contract, so it does not modify the state. We just read from the state of the contract. Again, we're going to be using the smart contracts controller, and then we're going to call the method called query. We pass it the contract address. We want to query the function called getSum to get the sum stored in the contract, and we pass it no arguments because it does not require any arguments. And if I run this, we see that we get the bytes value as 7. If we would have been using the ABI file, the SDK would have known to decode this value from bytes to an integer, and we simply have gotten the value 7. But this is the raw value returned from the contract. Okay, let's move on to interacting with the lottery smart contract using the ABI file. The deploy step very similar with it's very similar with the deploy step of the other contract. Again, we get the entry point, we set up Alice's account, we have the bytecode of the contract, but we also need to load the ABI file. So we have this, this is a JSON file, we have it stored here in this repository, and we simply load it by calling abi.load, and we then passing a path to the ABI. In case you haven't seen how an ABI file looks like, this is what it looks like. So it basically, it's an interface of the contract, so we know which endpoints and what types it needs, basically. So we see that the name is lottery. The constructor doesn't have any inputs, so it doesn't need any arguments when being deployed. And then we can see the endpoints. It has an endpoint called start that needs a lottery name, which has a type of bytes, a token identifier for which that will be used to buy the tickets. So the lottery contract, it's quite an interesting contract. It allows anybody to start a lottery and to set up a token to buy tickets for the lottery, and the amount of that token that a ticket costs. And after people buy tickets and the deadline ends, we can simply determine a winner, and the winner basically gets all the funds for that lottery. So it's quite interesting. Again, let's deploy the contract first. I'm just gonna run this so it executes. It finished executing after I finish talking. Again, we use Alice as the sender. We then set up the nonce. We pass it the bytecode and an empty array for the arguments because it doesn't need any arguments to be deployed. We see that the transaction has been sent with this hash, and the contract address is this one. I'm just gonna copy this so I can use it further in this workshop. Now, let me show you. You can also see the contract on the Explorer. So this is our just deployed contract. We can see that it's been first deployed 42 seconds ago, and there are no transactions for this contract so far. Now we want to start the lottery, so we're gonna start a lottery. Again, initialize the entry point, set up Alice's account, load the ABI file. This is going to be used to encode the arguments that we're gonna pass to the contract. We can simply provide the arguments as native Python values, and because we also pass it the ABI, it knows which types to encode those arguments. So here with the timestamp, I also set a duration, so the lottery will only have a duration of 2 minutes, because if I don't set a duration, I think it has a default duration quite a bit longer. So, and if that is not passed, I cannot determine a winner for the lottery. So I'm just gonna set it for 2 minutes. Hopefully it's enough to also buy the tickets before I go through this Jupyter notebook. Okay, so we create the smart contracts controller from the entry point. Then we use the create transaction for execute method. We pass Alice's account and nonce, of course. Then the lottery address that we've just set up here. We're going to call the function name start, and the arguments of the function are going to be these ones. This is the name of the lottery, so we're going to name it as lottery. We're going to use the token Alice to buy tickets for the lottery. Each ticket is going to cost 1 Alice token. If I'm not mistaken, this is the cap of the total cap of the tickets per user, which you're going to be setting as none. And these are some arguments that we can skip for now for this testing purposes. So if I run this transaction, this cell, I get a transaction hash, which means the lottery has started. Now I can also query the contract. I can do the querying process is the same as when querying the other contract, but we now pass it the ABI and the test lottery name of the lottery, and it automatically encodes it because we pass it the ABI. So we see that for this lottery, the token is Alice, the ticket price is 1, the tickets left are 800, the deadline, and so on. Okay, I'm gonna run these cells really quickly to buy tickets using Alice's account and Grace's account, just so we have the tickets bought. Now, to buy tickets using Alice, we initialize the entry point, again using the deadnet entry point with guess limit estimator set to true, and also this time we provided the guess limit multiplier. So the estimated guess limit that we'll get after simulating the transaction will be multiplied by 1.2 to get quite a bigger value, just to make sure the transaction executes. Okay, so now we set up Alice's account. We also set up the API. We get the smart contracts controller from the entry point. And now, because when buying token, what happens is called a transfer and execute, which means we also have to transfer some funds to the contract in order to execute the endpoint that we've specified. So we see that when calling the buy ticket method of the contract, we also have to specify the lottery we're buying tickets for, which is the test lottery name that we've set up before. And in order to buy the tickets, we also have to transfer one Alice token. This is the token that we've set the lottery to be using. So I ran this cell. We already got the transaction hash, and now we can see that we've sent 0.01 Alice tokens to the contract to buy the tickets. Very similar. We've done the same thing for Grace, but when buying tickets using Grace's account, I wanted to show you how you can do it using the smart contracts transactions factory instead of the controller. So very similar as above, we set up the entry point, set up Grace's account, set up the API, get the smart contracts factory, prepare the token transfer, which is the same because we buy the tickets using the same tokens, and each ticket costs 1 token. And now here, very similar as above, we pass it Grace's address instead of the whole account. The contract address, we want to buy the ticket for the test lottery, and also transfer the funds. Now, after the transaction is created, we set the correct nonce on the transaction, and then we proceed to sign the transaction. And after that, we also broadcast the transaction to the network. So if I take this transaction hash and paste it in the Explorer, we're going to see that we've sent from Grace to the same contract 0.01 Alice tokens to buy the ticket. Now, I'm going to query the lottery status to see if the lottery has ended and we can determine our winner. So if I run this cell, you see that I get that the lottery is ended. This looks like this because the SDK knows how to decode the value returned from the contract, because we've also passed it the ABI. So when querying, we also specified the contract's address. We wanted to call the function called status for the test lottery, and as we see, it's ended. So now I can determine the winner. If I run this, I'm gonna get the transaction hash. Okay, cool. Again, we trigger the determine winner of the contract using Alice. We set up the ABI and the controller, which is all kind of the same code as we've seen previously. We're gonna call the create transaction for execute method. We're gonna pass it the contract address. We're gonna call determine winner for the test lottery. And if I copy this transaction hash and paste it here, we'll see that the winner, it's been Alice, because the contract has transferred the funds to Alice. So when calling this this function, the contract executes the logic within itself and then sends all the tokens that are that have been accumulated in the contract for that lottery to Alice. Okay, so I think that's pretty much it for now. What we've done, we've interacted with the MultiversX blockchain using Python, using the official Python SDK. We've learned to create, sign, broadcast transaction, query account state, and also interact with smart contracts. If there are any questions, feel free to leave them in the comments below, and don't forget to check out the existing documentation. If you want to learn more and see what other capabilities the SDK has, you can also check out the multi-sig components, which can be used for multi-sig components, the governance components, which can be used to create new governance proposals, vote for proposals, the delegation components, which can be used to create a new delegation contract, to delegate funds, and so on, and the token management components if you want to issue new tokens, to create NFTs, and all that kind of stuff. Thank you for listening. Have fun building, and I'll see you in the next one. Bye bye.